Everyone, welcome to Mathematics Foundation, the YouTube channel. Today we are going to learn a new topic, relations and functions. That is the first chapter in class 12. Okay, let us see that. Relations and functions. Relations and functions. Before I begin, I just wanted to connect this part with the last year's portion. Class 11, you studied the Cartesian product. What is the Cartesian product? You all know how to draw the graph. How do we draw the graph? First of all, we draw a horizontal line. In the horizontal line, we mark the real numbers. This is a horizontal line we call x-axis. Then to draw the graph, we have another line called y-axis. It's a vertical line. So up it is, above the line it is positive. Below the line it is negative. Okay. So it is y-axis. Here, when you draw a graph, it shows a relation between the quantities between x and y. You know the graph which you learned in physics. You know the graph which you learned in mathematics. You know the graph which you learned in economics. Wherever you get the lines, which is a connection between the two axes. Here we have in the x-axis all the real numbers, and in the y-axis we can mark all the real numbers. So it's a relation, whatever the graph you draw is a relation between real number to real numbers. That's what we call x cross y, the Cartesian product of x and y. And this plane is called a Cartesian plane. And the points which you mark in the Cartesian plane, which are called coordinate points, which are all are ordered pairs. Now let us see a set, a non-empty set. Let A equal to 0, 1, 2, 3, which is a non-empty set, and B is another set, 1, 2, 3. So I am going to show this in the number system. That is 0, 1, 2 in there, 0, 1, 2, 3 here, and from the y-axis we are taking 1, 2, 3. Okay, so the Cartesian product A cross B is the connection between A and B. Is a connection between A and B. So that is 0, 1. First one is you take the connection 0 to 1. 0, 1, then 0 to 2, 0 to 3, and second 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3. So I will show the relation between A and B, that is A has 0, 1, 2, 3 and B has 1, 2, 3. So if you connect 0 to 1, there is the first element which is 0, 1, the ordered by 0, 1 and 0, 2 and 0, 3. Then we have 1, 1, 1, 2, 1, 3. 1, 1, 1, 2, 1, 3, then 2, 1, 2, 2, 2, 3, 2, 1, 2, 2, 2, 3, then 3, 1, 3, 2, 3, 3, 3, 1, 3, 2, 3, 3. Now all together there will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 elements are there in this set A cross B. So how can you find out the total number of elements in A cross B? A has 4 elements and B has 3 elements. So total number of A cross B is equal to 4 into 3 equal to 12 elements. This is the cross product. The cross product of the two sets A and B. And if it is in the real numbers, the x cross y, which will be a relation, which will be the cross product R cross R, real number to real numbers. Okay, so this is about the relation between the two sets. Therefore, if a set A has m elements and the set B has n elements, then A cross B, the cross product of a set A and B, are ordered pairs. All our ordered pairs will have m times n, which is mn elements. M times n, mn elements, and the total number of subsets of the relation is equal to 2 raised to mn. You studied in set theory how to find out the number of subsets. That is, if a set has n elements, the total number of subsets will be 2 raised to n, which includes it is empty set and the universal set. Okay, this is about the Cartesian product. Then next I will show an example here. If a set A is equal to, example, if A equal to 1, 2, 3, 4 is a given set, then find the set R such that R is equal to set of ordered pairs xy such that 3x minus y is equal to 0. 3x minus y is equal to 0. Now here we need to find out the ordered pairs xy from the given set. So we need to consider is a relation from A to B. It's a relation from A to A. We have only one set here, A to A. 1, 2, 3, 4. It is also 1, 2, 3, 4. And you know this A has 4. Therefore, there will be A to A relation will be having 4 to 4 equal to 16 elements will be there in the 16 ordered pairs will be there in the relation. But we need to choose the numbers in such a way that 3x minus 5 is equal to 0, where you take x from the first set and y from the second set. Okay, so if you let us take the first one. A has 1, 2, 3 elements. If you take x is equal to 1, 3 into 1, 3, so y must be 3. So that 3 into 1 minus 3 is equal to 0, which satisfies the equation. And if you take 2, 3, 2 are 6, but we don't have a 6 in B in the next second set, so that 3x minus 5 will be equal to 0. So we do not get another element, another pair which is satisfied the condition. Therefore, only the answer here is the ordered pair 1, 3, which only satisfy the given relation. And the next is the types of relations. Next we are going to learn the types of relations. Types of relations. First we are going to learn the relation which is empty relation. An empty relation is a relation which does not have any ordered pair. So we write a relation R is said to be empty relation are said to be empty relation if no element of A is related to any element of B. The relation R is said to be empty relation if no element of A is said to be any element of B. So there won't be any relation, and you know that R is a subset of A cross A. For example, A is equal to 1, 2, 3, 4, 5, and the relation R is defined by R is equal to the set ordered pair AB such that A minus B is equal to 10, where A and B both are the elements of. So this is the definition of the relation, and we have the set A equal to 1, 2, 3, 4, 5. Now if you consider the relation from A to A, the relation from A to A, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So A we take from first set and B from second set, and A minus B equal to 10. You can see that any element, if you take 1 minus 1, 1 minus 2, 1 minus 3, 1 minus 4, 1 minus 5, like 2 minus 2, 2 minus 3, 2 minus 4, 2 minus 5, 2, 5. So all together we can say 5 5s are 25 elements ordered pairs we can consider, but out of the 24 ordered pairs, none of the ordered pairs give the answer 10. So we can see this relation, there is no such ordered pair. Next is number 2, universal relation. Universal relation. A relation R, a relation in R is, a relation R in set A relation R in set A is called universal relation A relation R in set A is called a universal relation if each element of each element of A is related to every element of A. A relation R in set A is called a universal relation if each element of A is related to every element of A. For example, given set A, 1, 2, 3, 4, 5, and R is a relation from set A to set B. Sorry, R is the relation from set A to set A. So set A has already 1, 2, 3, 4, 5, and from set A to set A. So a relation R in set A is called a universal relation if each element of A, for example A is related to every element of A. So 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Likewise 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, 3, 1. So you will have the relation here 1, 1, 1, 2, 1, 3, 1, 4, 1, 5. Likewise 2, 1, 2, 2, 2, 3, 2, 4, 2, 5, then 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, which is same as A cross A. All elements A cross A. You know A cross A has 5 elements. B A has 5 elements. The A cross A will have 5 times 5, which is equal to 25 elements. We can see that 25 elements here. That is a universal relation. And next, third relation is reflexive relation. Next type of relation is the reflexive relation. So reflexive relation is a relation R in set A is called reflexive for every element A. For every element A belongs to A implies A belongs to the relation. For a relation R in set A is called a reflexive for every element A belongs to A implies A belongs to R. So if 1 is there in set A, then 1 must be there. If 2 is there in set A, 2 must be there. Such relations are called reflexive relations. Then next is symmetric relation. Symmetric relation. Symmetric relation is a relation R in set A is called symmetric. If A1, A2 belongs to R, which implies A2, A1 belongs to R. So if A1, A2, one pair is there, the same A2, A1 must be there. So those relations are called symmetric relations. In the relation, if A1, A2 is there, you will find A2, A1. If in the relation, if you find 2, 3, you will find 3, 2 also there. That such relations are called symmetric relation. And the fifth relation is called transitive relation. Transitive relation. Transitive relation is a relation R in set A is called transitive if A1, A2 belongs to R and A2, A3 belongs to R. If two sets A1, A2, A2, A3, which implies that then you will find out A1, A3. That also will be there. See, A1, A2 belongs to R, A2, A3 belongs to R, then you will find A1, A3. For example, say 1, 2. If you find 1, 2 in the set R, then 2, 3 also there in the set, then definitely 1, 2, 2, 3, then first and the last 1, 3 also will be there. So 1, 3 also must be there. So such relations are called transitive relation. So we studied here 5 relations. First one is the relation, empty relation, the relation which does not have any element. And the second relation, that is the universal relation, which is the cross product. If A has 5 elements, 1, 2, 3, 4, 5, then A cross A, all the elements in A cross A will be the universal set. Then here the 3 reflexive relation, symmetric relation and transitive relation. So in the reflexive relation, for every A in the set A, you will find the partner A. So for example, A is there in the set A, then A will be there. For example, 1 is there in set A, 1, 1 you will find. 2 is there in set A, 2, 2 also will be there. 3 is there, 3, 3 also will be there. Then symmetric relation is a relation in set A is called symmetric if suppose 2, 3 if you find in the relation, then you will find 3, 2 also there. Or if you find 4, 5 in the relation, then just opposite 5, 4 also will be there. So such relations are called symmetric relation. And transitive relation is there if A1, A2 is there, A2, A3 is there, then A1, A3 will be there. For example, 1, 2 is there, 2, 3 is there, then 1, 3 also must be there. So those relations are called transitive relation. And if all these 3 relations are together, for example, if a relation is reflexive, symmetric and transitive, so such relations are called equivalence relation. So equivalence relation. If the relation R is reflexive, symmetric and transitive, then R is called equivalence relationship. XY such that y is equal to x plus 5, where x less than 4. And x and y both belongs to natural numbers. X, Y are natural numbers. So we know the relation here is a relation from natural numbers to natural numbers. So the X is below 4, so 1, 2, 3. We need to take only 1, 2, 3 in the domain set. And the range, again natural numbers, 1, 2, 3, 4, okay. So when X is equal to 1, Y is equal to 1 plus 5, that is 6. And X is equal to 2, we get X is equal to 1, Y is equal to 1 plus 5 equal to 6. And X is equal to 2, we get Y is equal to 2 plus 5 equal to 7. 2, 7. X is equal to 3, we get Y is equal to 8. X is equal to, so we need to take only up to 3x, X should be below 4. So we get the ordered pairs in the relation, that is relation 1, 6, 2, 7 and 3, 8. Look at the relation now. In the relation we have only 3 elements, 1, 6, 2, 7, 3, 8. Okay, so here when X is equal to 1, you don't find out 1, 1 there, therefore it cannot be reflexive. So not reflexive. Not reflexive. And let us see the symmetric. Symmetric is if A1 is there, suppose 1, 6 is there, there must be 6, 1 also. So that 6, 1 is not there. If 2, 7 is there, that set need 7, 2. And if 3, 8 is fine, the 8, 3 also must be there. Therefore, it is not symmetric. It is not symmetric. And also it is also not it is not transitive because 1, 6 is there, again 6, 8 is there, then we can say 1, 8, but these things are not there, therefore it is not transitive. Okay, another example. Example 2. Example 2. Show that the relation R in the set R in the set A equal to 1, 2, 3, 4, 5 given by R is equal to the ordered pair AB such that modulus A minus B is equal to modulus A minus B is even number. This is an equivalence relation. This is an equivalence relation. Okay, once again, show that the relation R in the set A is equal to, in the set 1, 2, 3, 4, 5 given by R is the ordered pair AB such that A minus B is even and A minus B is equal to, A minus B is even. Its relation is the equivalent relation from A to A. Where A has 1, 2, 3, 4, 5, 5. So we need to find out the ordered pair A minus B is even, where A and B are both belongs to the A, B both are the elements of A. So now we can see 1 minus B. So what is, first of all let us start from 1. 1 minus 1, which is equal to 0. 0 is an even number. Then if you take 1 minus 2, 1 minus 3, 1 minus 4, 1 minus 5. So 1 minus 2 is negative, 2 is not even, 1 minus 3 negative 2. So 1 minus 2 is negative 2, and the modulus of 1 minus 2 is equal to 2, so which is even. And 1 minus 4 is negative 3, that is odd. 1 minus 5 is negative 4, modulus is equal to 4, which is equal to even. So with the 1 we are getting the ordered pair, that is 1 1, then 1 3, and 1 5. 3 elements. Okay. Then next, let's try from 2. So with the 2, we can take 2 1. So that is A is equal to 2 minus 1, then 2 minus 2, 2 minus 3, 2 minus 4, 2 minus 5. So 2 minus 1 is 1, so which is odd number. 2 minus 2 is 0, which is even number. 2 minus 3 is negative 1, again there is odd number. 2 minus 4 is negative 2 modulus is equal to 2, which is even number again. 2 minus 5 is negative 3, which is odd number. So here we have two pairs here, 2 2 and 2 4. So again 2 2, 2 4. Let's try the third number, that is with the 3. A in 3 from the domain set. So 3 minus 1, 3 minus 2, 3 minus 3, 3 minus 4, 3 minus 5. So 3 minus 1 is negative, 3 minus 1 is 2, even number. 3 minus 2 is 1, odd number. 3 minus 3 is 0, that is even number. 3 minus 4 is negative 1, again that is odd number. 3 minus 5 is negative 2, modulus is equal to 2, which is again even number. There we have 3 pairs here, 3 1, 3 1, then 3 3, and 3 5. Next we can take 4 from the domain. We can take 4 from the domain, that is modulus 4 minus 1, modulus 4 minus 2, modulus 4 minus 3, modulus 4 minus 4, modulus 4 minus 5. 4 minus 1 is 3, which is odd number. 4 minus 2 is 2, even number. 4 minus 3 is 1, which is odd number. So we don't take it. 4 minus 4 is 0, even. 4 minus 5 is negative 1, odd number. So we have 4 and 2, one pair. 4 and 2, then 4 and 4. Last we take the number 5 from the domain set, and modulus 5 minus 1, 5 minus 2, 5 minus 3, 5 minus 4, 5 minus 5. 5 minus 1 is 4, even number. 5 minus 2 is 3, odd number. 5 minus 2 is 3, odd number. 5 minus 3 is 2, that is even number. 5 minus 4 is 1, odd number. 5 minus 5 is 0, even number. So we have 5 1, 5 3, 5 5. These are the pairs which satisfy the relation R. So it has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 elements ordered pairs you will find in the relation. Now let us see whether it is symmetric, reflexive and transitive. So you know the reflexive say that if one element A is there in A in the first set, then A you will find it. For example, in the first set 1 is there. So 1 is there in A, you will find out 1 1. Search 1 1 is there. So 2 is there in A, so you can find out 2 2. 2 2 is there, right? Then 3 is there in the first set, so 3 3 also there. You can find out 3 3 there. Then 4 is in the set A, therefore you will find 4 4. 4 4 also there. Likewise 5 is there in the set A, 5 5 is there, therefore it is reflexive. R is reflexive. R is reflexive. Next we can see symmetric. The relation symmetric. Symmetric says that if 1 1 is there, sorry 1 3 is there, you will find out. 1 1 is there, definitely 1 1 is there. So symmetric says that if A1 A2 is there in the relation, then there must be A2 A1 also. So for example 1 1 you don't have to see, because 1 1 if you reverse also 1 1. 1 3 is there, you will find out 3 1 also. Right, 3 1 is there. Okay. Then 1 5 is there, you will find out 5 1. Yes, it is there. 2 4, you will find out 4 2 also. Okay, it is there. Then 3 1, we found already 1 3. Then 3 5, 5 3 is there. Then 4 2, 2 4 is there. 5 1, 1 5 is there. So I think all the pairs we will find out just opposite there. Therefore it is, R is symmetric. Likewise we can see that 1 3 there. Next one is transitive. Transitive, what is the rule of transitive? A1 A2 belongs to R, then A2 A3 belongs to R, then you will find out A1 A3. For example 1 3 is there, 1 3 is there, and 1 5 is there. 1 5 is there, 1 3 is there, 1 3 is there, 3 5 is there. So 1 3 is there, 3 5 is there, then 1 5 also must be there. You will find 1 5 here, okay, 1 5 is there. Then 1 2 is there, 1 2 is there, 1 2 is not there. Okay, I think this is all. So it is, R is transitive. R is transitive. So it is reflexive, symmetric and transitive, therefore R is equivalence relation. Equivalence relation.